Wally Gilbert, the father of modern production engineering, plotted the bottom hole flowing pressure versus the flow rate and referred to this curve as the inflow performance relationship, or IPR. This is a typical curve for a given average reservoir pressure. The reservoir pressure will generally be depleted by production, so the IPR over the life of a well may be shown by a family of curves shrinking toward the origin. Each curve represents the pressure rate relationship at a given average reservoir pressure. The endpoints of the IPR curve are the average reservoir pressure at a flow rate of 0 and the maximum potential flow rate Q prime at a bottom hole flowing pressure of 0. Q prime, called the pumped off potential or open flow potential of the well, represents the ideal maximum flow rate that would occur if we could reduce the bottom hole pressure to 0. In practice, it is not possible to achieve this rate because the bottom hole flowing pressure must always have some finite value. Above the bubble point, the IPR curve is a straight line, and the productivity index, the slope of the IPR curve, is constant. Below the bubble point, as gas comes out of solution and begins to interfere with flow, the curve trends downward. This particular shape is characteristic of reservoirs with a solution gas drive. Reservoirs with other drive mechanisms, such as water drive, gas cap expansion, gravity segregation, or a combination of mechanisms, will have IPR curves of a different shape, or perhaps a straight line. To be accurate about the specific pressure being discussed, you will note that the vertical axis label P sub WF changes to P when other pressure rate curves are presented. We will continue to use this procedure in all future modules.